50 says, write the column matrix B as a linear combination of these columns. So let's solve it first. Solve the system. AX equals to B. So we need to form the augmented matrix. AB. Okay, here we go. Let us start. 1, negative 1, 0, 2, 0, 1, 4, 2, 3, and then last row, last column, 1, 3, 2. And our goal is to convert this into reduced form 1, 0, 0, 0, 1, 0, 0, 0, 1, and some elements that you end up in the last column. So this is our goal. Luckily for us, this is 1, but this time must be 0. So we're going to add R1 to R2, and this is going to be your new R2. So this is 0, 2 plus 0, 2, 4 plus 2, 6, 1 plus 3, 4. Okay, this is 0, so we're not worried about that. We're having a nice first column. Let us move on to the second column. In the second column, this guy must be 1, and these two must be 0. So let us divide R2 by 2. And this is going to be our new R2. 2 divided by 2, 1. 6 divided by 2, 3. 4 divided by 2, 2. We're going to multiply the second row by negative 2 and add it to the first row. Negative 2R2 plus R1 becomes our new R1. This doesn't make any changes. Negative 2 plus 2, 0. Negative 6 plus 4, negative 2. Negative 4 plus 1 gives us negative 3. This guy must be 0. So we're going to multiply the second row by negative 1 and add it to R3. And this is going to be our new R3. So this doesn't change anything. This is going to be 0. Another 0. And negative 2 plus 2 is 0. Okay. Let us use this new matrix and write the system of linear equations. This guy says, hey, I have x minus 2z equals to negative 3. This guy says, hey, y plus 3z is 2. And the last row says 0x plus 0y plus 0z is 0, which is always true. But note that here we have 2 equations with 3 variables. So what's the meaning of that? It means that we need to introduce a parameter. We need a parameter. So it's easier to take t to be equal to, for example, z. And t is a real number, just a parameter that you're using. T belongs to r. So by doing that, what happens is x is equal to 2t minus 3, and y is equal to 2 minus 3t. So if I ask you to write a solution, you're going to say that, hey, it is 2t minus 3, comma, 2 minus 3t, comma, t. And t belongs to r. So you have infinitely many solutions here. You can just take this parameter, anything that you like. You can take t to be, for example, equals to 1. If t is equal to 1, you end up having negative 1 and negative 1 and 1. If t is equal to, for example, 2, anything that you like, you're going to end up with 1, and then here you have 2 minus 6, which is negative 4 and 2. You have infinitely many options. If t is equal to negative 1, you're going to end up having negative 5. Then here you're going to see 2 plus 3, which is 5. And then here you have negative 1. You have infinitely many options here. Now you can use either of these options and write B in terms of these 3 columns. So my B, 1, 3, 2 can be written this way. I can use this, or this, or this, or infinitely many options that I have. If my t is equal to 1, my x becomes negative 1 times the first column, the scalar multiplication, plus negative 1 times the second column, 2, 0, 1, plus 1 times the last column, 4, 2, 3. You can double check this as well. Check. Negative 1 times 1, negative 1. Minus 2 plus 4. I have 4 minus 3, which is 1. This element here. Negative 1 times negative 1, 1 plus 0 plus 2 is 3. This is just right here. There I have 0 plus negative 1 plus 3, which is 2, which is just right here. Again, I use this one. You may use this or any other combination that you like. It just says as a linear combination, one of them.